Welcome. Today we're going to be looking at just the unit circle practice. And so all you need is a blank piece of paper. You're going to have your study guide, but I'm going to ask you to kind of put it off to the side and maybe even face down. And what we're going to just do is try to go through a variety of these and see if we can figure out some strategies and ideas to get you to really know them pretty well. So I guess the first order of business, everyone, is to draw a fairly large circle on your paper there. I'm going to try to do my best up here. And not great by any means, but it'll have to suffice. And when you get an opportunity, everyone, let's go ahead and throw just sort of the coordinate plane aspect of it right there. And this is good, something like that. And then actually just kind of thinking about this, already I've got a few of those special t values in each of those 4 points. And remember, if you've gone a quarter of the way around the unit circle, you've gone exactly pi over 2 units. And by the way, this kind of gets lost in the shuffle sometimes, but pi divided by 2 is about 1.57, give or take. And so let's put that in there. I think that's going to be useful with some of the things we're going to do today. If I've gone halfway around the unit circle, I've gone exactly pi units. And pi is about 3.14, give or take. I'll just kind of round that to 2 decimal places. So again, if I've gone halfway around, I've gone just over 3 units around. Let's see, if I've gone 3/4 of the way around, then I've gone exactly 3 pi divided by 2 units. So let's go ahead and put that there. And this would be about 4.71, give or take. If you were to take 3 pi and divide it by 2 on your calculator, you should get about 4.71 somewhere in there. And if you've gone once around the unit circle, then you've gone exactly 2 pi units, which again is about 6.28, give or take there. Good, I think that's going to be, again, helpful for some of the things that we do. Alrighty, a couple other ideas here. Let's see, those 3 numbers that came up really all throughout our construction, 0.5 everybody, is that 1/2. The root 2 over 2 is about 0.707, and root 3 over 2 is about 0.866. So I'm going to ask you really to kind of compare those. So if I ask you about the smallest of those 3 numbers, obviously you're going to talk to me about 1/2. What's the middle of those 3 numbers? Root 2 over 2. And what's the largest of those 3 numbers? That's the root 3 over 2. So just being able to compare those 3 numbers is actually key to being successful with the unit circle. All right, now guys, let's go ahead and draw in just some of our special t values, kind of doing our spokes in the wheel. That's sort of the analogy here. So it does not have to be perfect here. Again, you already constructed this. But something like that, first and third quadrants. And then if you get an opportunity here, let's just go ahead and draw some in the second and fourth quadrants. Didn't do a good job on that one, but oh well. So something like that. Again, not going to be perfect there, but it'll have to do. Okay. And so the way I've divided some of these questions up, in fact, I have on my paper 8 different categories that we're going to look at. 8 categories there. And we're going to start it out very straightforward, just nice and easy. What I'm going to ask you to do very simply is pause the video every time I give you one. Think about it. Write down an answer, or just think of the answer. And then quickly come on back and let's see how you did. I'm going to be a little rapid fire with this. So I'm going to give you one, expect an answer. Give you one, expect an answer. And you'll see as you get better and better at this, you're going to get really quick with these. So here's how I've kind of titled the first one here. You don't have to write this on your paper, but the first one's just quadrants. Understanding where you are on the unit circle. So what I'm going to do very simply is give you an angle measure, and I need to know which quadrant it's in. And then I'd ask you to take the next step of pinpointing it. Just point to it on your unit circle. Where are you on the unit circle with this particular number? Okay, so the first one I'm going to give you, everybody, is 3 pi over 4. And 3 pi over 4, again, think about which quadrant it's in. If you want to pause, pause. But very simply, 3 pi over 4 is in the second quadrant. And which one of these 3 terminal sides is 3 pi over 4? It's this one right here. So 3 pi over 4 is that value right there. So quadrant 2 for 3 pi over 4. Okay, next one. And this said every time I give you one, if you want to just pause, that's fine. Or if you want to hear me talk you through it, that's fine as well. 7 pi over 6. Where is 7 pi over 6 on the unit circle? Think about which quadrant. Is it closer to the x? Is it closer to the y? Or is it in the middle out of the 3 terminal sides? And 7 pi over 6, everybody, is a third quadrant angle, 210 degrees, by the way. And all the pi over 6s are the ones closer to the x-axis. So there is 7 pi over 6. Right there, everyone. Okay. Next one coming your way. How about 2 pi over 3? Where is 2 pi over 3 on the unit circle? Okay, well, 2 pi over 3, if you can envision it, again, I always go degrees with this. If I can't sort of figure it out through other means, 2 pi over 3 would be 2/60, which is 120, and I should be able to envision 120. So 120 degrees would be a rotation from here to here, which means everybody 2 pi over 3 radians on the unit circle, or 2 pi over 3 units, is right up there. And remember, we saw all the pi over 3s are closer to the y-axis. So here was 1 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, next one. How about this one? How about just pi over 6? Point to it, see it. Can you envision yourself on the unit circle at pi over 6? Pi over 6 should be right there in the first quadrant. All the pi over 6s are closer to the x-axis. Here's 1 pi over 6 in the first quadrant, 5 pi over 6, 7 pi over 6, 11 pi over 6. So know which quadrant you're in and compare it to the other two. Where are you? Okay, next one, 7 pi over 4. Where is 7 pi over 4 on the unit circle? Well, 7 pi over 4 is in the fourth quadrant. Fourth quadrant, and all the pi over 4s are the ones that split. By the way, nice pattern with the pi over 4s. I like this one. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And so 7 pi over 4 is the one in the fourth. Okay, let's keep going. How about this one? How about 5 pi over 3? Where is 5 pi over 3? Okay, if you remember correctly, 5 pi over 3, and by the way, I've seen students mix up 5 pi over 3 and 4 pi over 3 quite a bit, just not knowing which is which. 5 pi over 3, everybody, is right there in the fourth quadrant, 300 degrees, just past the 270. So closer to the y-axis in the fourth quadrant. 5 pi over 3. Excellent. How about just a couple more here with these exact ones, and then start getting into a couple other ideas as well. How about this one right here, 5 pi over 4. 5 pi over 4. Which quadrant are we in? 1, 2, 3, or 4? Well, everyone, it looks like 5 pi over 4 would be right here. There's 5 pi over 4. Third quadrant, splitting it right in the middle. So third quadrant on that. And then the last exact one that we'll do, how about this one? 11 pi over 6. Where is 11 pi over 6? Okay, well, 11 pi over 6 would be 330 degrees, almost all the way around, but it should be right there in the fourth quadrant. Again, pi over 6 is closer to the x-axis. So fourth quadrant on that one. Okay, hopefully that works out well. As I said, before we can start talking about sine and cosine and stuff like that, that is our first order of business. Where are you on the unit circle? Let's do one more thing with quadrants here as I'm kind of thinking about it, and then we'll get into the next step. Now remember, everyone, these are what are called our special t values that we've been looking at. We also want to look at the fact that t can be any real number. So I guess using the idea that I had you right at the beginning, the pi over 2, the pi, the 3 pi over 2, and the 2 pi, talk to me about these. Which quadrants would these t values be in? So think about it for a sec. A little different, a little new, but what if I said, hey look, you're going 2.1 units around the unit circle. Which quadrant would you be in? 2.1 units around the unit circle. Where would you be? Well, if you look at the way we've divvied this up, the coordinate plane, pi over 2, which is about 1.57 units, is up here, and pi units is over here at 3.14, so 2.1 units probably has to be somewhere in here, somewhere give or take. So it's quadrant 2. Okay, good. Okay, how about this one? How about, what if I said 4 units? If you went 4 units around the unit circle, where would you be? Which quadrant? And if you look at the way we've broken up the quadrants here, pi units is right here, 3 pi over 2, which is above 4, is here, so 4 units has to be somewhere in between here. 4 would be in quadrant 3. Hoping you're understanding that piece. If not, again, please ask at any point. How about this one? What if I asked you where 5.91 units were on the unit circle there? Again, I'm just making numbers up, to be honest. T can be any number. So what if T is 5.91? Where would you be? Well, based on our breakup here, 4.71 is here, 6.28 roughly, again, is here. So 5.91, probably a little closer to that x-axis than the y, probably somewhere in there. Okay, so quadrant 4. All right, good. So I'm hoping you're understanding that aspect of it, that T can be any real number, and we'll look at some of those a little later on. All right, now let's get into the next piece. Let's start just talking about sine and cosine of some of these good ones right here. So, primary rotation, sine and cosine. Let's see what we can do. So, here we go. Starting it out, everyone, what if I asked you this? What is the sine of pi over 3? So, first and foremost, if we're going to go ahead and do this, here's how I would visualize it, and I'll slow down just a touch. The first thing I need to know is, where is pi over 3 on the unit circle? So, I would sort of picture myself right here, everyone. I hope you're doing the same. There's pi over 3. Now, as soon as I hear the word sine, which letter do I think about, everyone? The x or the y? I think about the y. And now, remember, with the y coordinate, we're going to think vertically. Y is vertical on the coordinate plane. X is horizontal on the coordinate plane. So here's what I'm thinking with this one. If I'm up here at pi over 3, and I want the sine of pi over 3, I know it's going to be one of these 3 numbers, either 0.5, or I should say 1/2, root 2 over 2, or root 3 over 2. If I compare myself vertically with the other 2 terminal sides in the first quadrant, the question, of course, becomes, is it the smallest as I go vertically? Is it the middle one as I go vertically? Or is it the highest as I go vertically, the largest as I go vertically? And so if you compare this to the other 2 vertically, it looks like here's the first one. That's the lowest. Here's the second one. There's the middle. Here's the third one vertically. That's where we are. We are the largest one vertically from here, right there. So, the largest out of those 3 numbers is the root 3 over 2. And so the sine of pi over 3 is root 3 over 2. Again, we'll continue to work on this as we go through. Okay, next one. Let's see if we can visualize this one. How about cosine of pi over 4? Now, the first, again, order of business is to know where pi over 4 units is on the unit circle. Pi over 4, everybody, is right there. So, as soon as you hear cosine, you're thinking x. As soon as you think x, you're thinking horizontal. So, start working across your x-axis. And right here, everyone, here's the terminal side. Here's where it hits the unit circle. The question is, as I go horizontally, do I get to that terminal side first, second, or third? Is it the smallest? Is it the middle? Or is it the largest? And as I work, here's the smallest, which would match up with this one horizontally. Here's the middle, which matches up to the one we want. And then here's the largest, which matches up to this one right here. So one more time, as I work horizontally, do I get to my point the smallest, the middle, or the largest? And in this case, I get to it in the middle. And so the cosine of pi over 4 is in the middle of those three numbers. It's root 2 over 2. Okay, that's how I'm going to envision those. Let's continue into some of the other quadrants. I think that would be helpful. Let's see. I'm just going to keep going back and forth. How about this one? Sine of 5 pi over 6. Okay, so the first order of business, everybody, is to know where 5 pi over 6 is. It's in the second quadrant, and it's right there, the one closer to the x-axis. So everyone, there's 5 pi over 6. Now, as soon as I hear sine, I think y. As soon as I think y, I think vertical. And in this case, compare it to the other two terminal sides in the quadrant. As I go up, is it the first one I hit, the second one I hit, or the third I hit? Is it the smallest, the middle, or the largest? In this case, if you look, up, as I go up, I hit it right away. That's the first one I hit. So it's the smallest vertically. And if it's the smallest vertically, then the sine of 5 pi over 6, everybody, is 1/2. And that's how I would encourage you to see these, really. Okay, let's keep going. How about this one? Let's do the cosine of, how about 4 pi over 3? So what's the cosine of 4 pi over 3? Again, be very careful. A couple reasons for this one. First of all, see 4 pi over 3. Here, everybody, is 4 pi over 3, right there. That's where I am on the unit circle. As soon as I hear cosine, I'm thinking x, and I'm thinking horizontal. Now, careful here. I'm going to start out kind of at the origin and go horizontally. I'm going to go on my x-axis. And the question is, am I going to get to that particular point? Am I going to get there first, second, or third with those three terminal sides in this quadrant? Here's the first, second, and third. And so let's think about this. Do I hit it first, second, or third? Looks like I hit it right away there. I hit it first as I go horizontally. So in this case, it's the smallest of the three numbers. Here's where we have to be careful, though. Notice direction. I went left. And direction matters in trig, as we've said before and say again. But if I go to the left, then the cosine value has to be negative. So it's negative 1/2. Okay, let's keep going. More practice. It's good stuff. Let's go cosine. Nope, did that one. Let's do sine of 7 pi over 4. Okay, so let's see. 7 pi over 4, everybody, is right here. There is 7 pi over 4. Sine, think y, think vertical. And I'm going to go start here at the origin, and I'm going to go vertically. In this case, I'm going down to get to 7 pi over 4. So we know sine of 7 pi over 4 is going to be negative. And as I go down and compare it with the other two terminal sides in the quadrant, do I hit it first, or second, or third? So as I go vertically, everybody, here I am. Do I hit it first? Nope. Do I hit it second? Yep, there it is. 7 pi over 4, I hit second. And so as a result, it's the middle of those three numbers. I went down, and so it's negative root 2 over 2. Okay, a couple more of these, and then we'll up the ante a little bit, do some more with this. Let's do cosine. Let's see, try to find a good one for cosine. How about cosine of 7 pi over 6? Good hard one right here. Okay, 7 pi over 6, everybody, is right there. Third quadrant, have to know that. Can't do this without it. So cosine of 7 pi over 6. So let's think horizontal. Again, I'm going to start here, and I'm going to go horizontally. You tell me if I'm going to get to here horizontally, do I hit it first, or second, or third? And as I go over, here's first, here's second, here's third. Right there. So if you can kind of visualize it, there's your negative 0.866. So I hit it third, and so it's the largest of the three numbers, and it's negative. Cosine of 7 pi over 6 is negative root 3 over 2. Okay, let's try a couple others. How about this one right here? How about sine of pi? So as we all know, pi is, let's visualize it, halfway around. There we are. And think about this. What is the y coordinate right there, everyone? What's the y coordinate? And it's 0. Sine of pi is definitely 0. Okay, next one. Let's do this one. How about cosine of 2 pi? So what would cosine of 2 pi be? If you go 2 pi, you've gone once around the unit circle, and you end up right there. As soon as I hear cosine, I'm thinking about that x value. What is the x coordinate all the way out here? And the x coordinate, of course, is going to be positive 1. So cosine of 2 pi is positive 1. Okay, let's continue. How about this one? How about sine of 3 pi over 2? So where are you if you've gone 3 pi over 2? Well, it's written up here, so let's take a look. I'm at the bottom of my circle, everybody. There's 3 pi over 2. And what is the y coordinate all the way down here? Well, again, sine, think y, think vertical, all the way down at the bottom. And sine of 3 pi over 2 is going to be negative 1 as a result. Okay, let's see, maybe one more here. How about this one? How about cosine of pi over 2? And if you look up here, here's cosine, or here's pi over 2, I should say. So there's pi over 2. And what is the x value up there? What would be the x coordinate at that point on the coordinate plane? The x value is 0. So cosine of pi over 2 is 0. Okay, so it's looking pretty good. I wouldn't mind doing a couple more sine cosines, because those are the most prevalent ones that we're going to see. So let me throw a couple more up here, and then we'll go into the next topic that I've got. So let's see, let's do sine of, let me catch one that I haven't seen before. How about this one? How about 4 pi over 3? Actually, let's do 5 pi over 3. I haven't seen that one yet. So sine 5 pi over 3. Okay, find 5 pi over 3. Point to it on your unit circle, everyone. 5 pi over 3 is right there. And so whenever I hear sine, I think vertical. And let's go. We're going down, so it's going to be negative. Do I hit it first, second, or third? Is it the smallest, the middle, or the largest out of those 3? And as I go down, I hit, there's the first, there's the second, and there's the third. Matching it over vertically, there's the third. And so as a result, it is the largest of the 3 numbers there into the negative. Sine of 5 pi over 3 is negative root 3 over 2. Okay, one more here. Let's see, let's find a good one. Okay, how about this one? Cosine, and let's go 3 pi over 4. Okay, so let's find 3 pi over 4, everyone. Should now start to see these in action. 3 pi over 4, everybody, is right there in all its glory. Cosine, think horizontal. Here we go. Start there and then go horizontal. Do I hit it first, do I hit it second, or do I hit it third? As I go horizontal, everybody, there's first. Nope, didn't hit it yet. There's second. Yep, there it is. There's your 3 pi over 4, and I hit it second out of the 3. And so as a result, it is the root 2 over 2, but again, be careful, guys. In this one, really, signs do matter. If you give me root 2 over 2 instead of negative root 2 over 2, it's dead wrong, really, quite wrong. So cosine of 3 pi over 4 is negative root 2 over 2. Okay, so a good problem set right there. You're obviously going to get some practice with this on the homework that goes with it, and a take-home quiz as well. Really, again, the hope is you're starting to do these without your study guide. You're going to wean yourself off it, but use it to help you and see it. Next one, everyone, let's do tangent. So that's my next category right here, tangent. And we'll just do a few of these, give you a couple ways to remember some of them. So let's start it out. How about this one, everyone? Tangent of 3 pi over 2. So here is 3 pi over 2. Now remember, we have to be a little careful here because we have to know both the x and y. So tangent is the ratio of y to x. And very simply down here, the y is negative 1, and the x is going to be 0. So I think of this as knowing where you are. The y is negative 1, and the x is 0. And so as a result, tangent of 3 pi over 2 is undefined. Perfect. Okay, how about this one? How about tangent of pi? So again, let's see pi units right there. Y over x, everybody, really have to envision that point. That point would be negative 1, 0. And so in this case, the y value is going to be 0, and the x value is negative 1. 0 divided by anything, in this case 0 divided by negative 1, is 0. Good? Okay. Now let's go get the pi over 4s. So tangent of pi over 4, this one's a good one, at least to kind of remember. Think about the x's and y's. There's pi over 4, everybody, on the unit circle. What do we know about x and y actually at that particular point? Well, if you look at your study guide, they're both the same. They're both that root 2 over 2. And so anytime I take a number and divide it by itself, root 2 over 2 over root 2 over 2, if you want to think of it that way, anything divided by itself is 1. So tangent of pi over 4 is actually 1. We're going to see this come up when we look at right triangles as well. Okay, how about this one then as a result? How about tangent of 7 pi over 4? Okay, now let's go ahead and get into that fourth quadrant. Everyone, 7 pi over 4 happens to be right there, looking great. Well, same deal, guys, at all the pi over 4s, they're both of those root 2 over 2s for both x's and y's. The only thing I have to be careful of is when I divide is one is positive and one is negative. In this case, it just so happens the y is negative and the x is positive. And so as a result, when I divide those together, I end up getting negative 1 as a result. So tangent of 7 pi over 4 is negative 1. So think about just where tangent is positive and negative, everyone, just as we go through, because you're going to divide x's and y's. First quadrant, both coordinates are positive. So divide them, tangent's going to be positive in the first quadrant. Second quadrant, x is negative, y is positive, so when I divide, tangent's actually negative. Third quadrant, everybody, think about this one. This is a good one. Third quadrant, x is negative, y is negative. What happens when I divide them in the third quadrant? Tangent's going to be positive. And fourth one, as we just saw, you've got x is positive, y is negative, and when you divide them, everybody, you're going to get a negative tangent value. So if I asked you for tangent of 5 pi over 4, pretty much right away, you know it's either going to be 1 or negative 1. And in the third quadrant, here we go, third quadrant right there, negative over negative, everyone. Tangent of 5 pi over 4 is 1. Okay. Now, guys, let's go into the 3s and 6s. So here's the idea. What you saw on your unit circle construction yesterday is that the tangent of pi over 6 is root 3 over 3. Tangent of pi over 3 is just root 3. Now, I've got a very silly way to kind of remember these, because I've seen students over the years confuse the two and switch the two. So here's just a simple way to remember it. I don't know if it works for you, but here's the idea. Guys, take a look at these numbers. What's 3 plus 3, everybody? 3 plus 3 is 6. So the tangent of pi over 6 is the root 3 over 3. Whereas this one just has the 3. And so the tangent of pi over 3 is just root 3. So just think, 3 plus 3 is 6. So that's what goes together. Tangent of pi over 6 is the root 3 over 3. Tangent of pi over 3 is just root 3. Okay, so I don't know if that helps or not, but got to know those in some way, shape, or form, because now, everybody, what happens when I ask you this? Tangent of 5 pi over 6, which one is it going to be? Well, it has to be a root 3 over 3. I just have to be careful of the signs. 5 pi over 6, everybody, is in the second quadrant right there. And you have a negative x and a positive y. And so when you divide them, it's going to be this right here, negative root 3 over 3. Okay, a couple others. How about this? How about tangent 5 pi over 3? 5 pi over 3, everybody, is fourth quadrant right there. As soon as I see tangent of pi over 3, it definitely has to be a root 3. The only question is it positive or negative? If we're in the fourth quadrant, everybody, remember in the fourth quadrant, x is positive and y is negative. So when you divide those two, tangent has to be negative in the fourth quadrant. Okay, that's pretty good there. I hope that helps. Again, you're going to get some more practice on your own with tangent. But again, the root 3 over 3 goes with the 6. The root 3 goes with the 3. Okay, let's go into my next topic up here. Don't want to spend a ton of time, but some really good stuff with this. And you're going to get better and better. And it's not just memorization. As I said, it's more visualization than anything. I certainly don't memorize these. I visualize where I am on the unit circle, and then I can see the value based on the way I've described it. Okay, next one. Let's go with this. Negative t values. Okay, so let's try just a couple of these to get ourselves started. Again, more practice. How about this? What if I asked you for the sine of negative pi over 4? So, can we have a negative t value? Of course. What does that mean moving around the unit circle? All it means is that we're going clockwise as opposed to counterclockwise. So now your study guide doesn't have these t values, but that's all right. All it means is we start here and we go pi over units clockwise. Well, if I went pi over units clockwise in terms of my special t values, I think we would hit it right here. This would be negative 45 degrees as an angle measure, negative pi over 4 radians, and so negative pi over 4 units around the unit circle. Again, all you have to know is where you are on the circle. If you know where you are, you have a shot. And in this case, if I'm right here, everybody, then I start thinking the same way I did before. Sine, vertical. So let's go ahead and go down here from here. Am I going to hit it first or second or third? There's first. Didn't hit it. There's second. Yep, I hit it. So I hit it second, and so it is negative root 2 over 2. I went down. Perfect. Okay, how about this one? How about cosine of negative pi over 3? Okay, so negative pi over 3 just means a clockwise rotation from here, pi over 3 units. Right there, everybody. That's the one. Okay, and so let's see this in place. Cosine, think horizontal. And am I going to, as I go horizontally, in this case I'm going to go to the right to get to this spot. Am I going to go to the right? Am I going to hit it first, second, or third? And as I go, I hit it first. I definitely hit it first. And so going to the right, hitting it first, it's the lowest number. It's 1/2. Let's try maybe just one or two more of the negatives and just keep this going. How about this one? How about sine of negative 5 pi over 6? Okay, so this is a good one right here. Remember, that's about 150 degrees clockwise. So that would be going around right before, probably halfway. I think negative 5 pi over 6 would be right here. And so if you know you're right here, then let's start working our way. Here's where I'm going to start. Am I going to hit that spot going down vertically? Am I going to hit it first, second, or third? And if you look, it looks like I hit it first. So there it is, right there. I hit it first. And so as a result, there's your answer. Sine of negative 5 pi over 6 is negative 1/2. Okay. Again, I don't want to belabor the point too much on negative t, but you should be comfortable with the fact that, t can be any number. Even though we didn't write them explicitly on our study guide, should be able to pull that off. Okay, next one. Let's go. I would call this the post-primary rotation. Do just a couple of these, get us thinking about it. So let's see, how about this one to start? Let's do sine first. How about sine of 9 pi over 4? And so think about this one. Well, remember, in terms of the pi over 4s, this was 1 pi over 4. This one was 3 pi over 4, 5 pi over 4, 7 pi over 4. And as you can see, 9 pi over 4, it means I'm going to go around again. 9 pi over 4, following the pattern, probably puts us right here. You could always change to degrees and then think about 9/45 should be 405 degrees, and then kind of work your way through. But ultimately, again, got to figure out where you are in the unit circle. I would be right there. And sine of 9 pi over 4 as a result is root 2 over 2. So you could see the sine of 9 pi over 4 is going to be the same as sine of pi over 4, because the values just repeat if I'm in that same spot. That's a big thing in trigonometry, the idea of repetition. Okay, good. How about maybe just, again, one or two others? Let's do cosine of 3 pi. So what's cosine of 3 pi? Well, let's think about pi. So 1 pi is halfway around. 2 pi is all the way around. So 3 pi puts me probably right back here. And if I'm right there, everybody, I'd think about the x value right there, and the cosine of 3 pi is -1. Good. Do one more here. How about sine of, let's do, let's do this one. How about sine of 7 pi over 3? So we're just going to have to think about what this is. Here's pi over 3, and then 2 pi over 3, and 4 pi over 3, and 5 pi over 3. So now we're going beyond. There's 2 pi, everybody. I don't know if it helps you think degrees. 7 pi over 3 would be 7/60. So that would be 420 degrees. And so let's see, that would be 360. And then it means another 60 left. So I'm seeing, and again, going to have to work through some of these, but I'm seeing 7 pi over 3 be right there. And as a result, again, think vertically on this one. This is a good one. Going up, do I hit it first, second, or third? Here's first. Here's second. Here's third. I hit it third. And so sine of 7 pi over 3 is root 3 over 2. Okay, good. Doing great. Let's see. Let's do just a couple of the reciprocals. So we didn't write those in our study guide, but I think we can still work out some of these. All right, so let's start it out. How about something like this? How about cosecant of pi over 6? So as soon as you hear the word cosecant, you're thinking sine. And so if you know the sine of pi over 6, which you should, here's pi over 6 right here, everybody. And I'm hoping everybody would be in agreement that the sine of pi over 6 is 1/2. And all you have to do is flip 1/2. So it's almost like this. We're going to see this kind of later on in this unit sort of described that way, but that's basically what it is. And I'm just kind of thinking out loud. I'm going to show you another way to pull this off, but basically it's that. And as long as you know that sine of pi over 6 is 1/2, all you have to do is flip 1/2, and the cosecant of pi over 6 is just 2. So just flipping the sine value, basically. What if I asked you for the secant of pi over 6? Well, again, what I would do is just ask myself, what is the cosine of pi over 6? And cosine of pi over 6 is definitely that root 3 over 2. So flip root 3 over 2. That would be this right here. Rationalize it, and we've done this now a couple times before. And this would be the secant of pi over 6. How about maybe one more here? How about cotangent of 0? Good one. So a couple ways to do this one. You could either do it as just x over y. Remember, cotangent is defined as the x over y. That's probably the way to go here. Or you can find tangent and flip tangent. I kind of like the x over y here. So remember, 0, by the way, is a t-value, puts you right here. And x over y, well, that would be, in this case, 1 over 0. And again, it looks like undefined in this case. Cotangent of 0 is undefined. Okay, maybe one more of these. How about this? How about cosecant of pi over 4? So think sine pi over 4. Sine of pi over 4, of course, is root 2 over 2. And flip root 2 over 2, you get 2 over root 2. And if you remember, when we rationalized this 2's cancel, and you end up getting just root 2. Okay, good. So the secondary ones, the reciprocals, hopefully that just kind of gets you thinking about how to pull them off. Let's start to narrow this down a little bit. I'm just kind of looking at the time here. Don't want to spend a ton on it. How about this now? Kind of the last couple of pieces. Let's do those and wrap this on up. So here's what I'll ask us to do for this. Basically, I'm going to put a t value up with a trig function. All I want you to tell me is it positive or negative? And so here's what I'm thinking. How about this? What if I asked you for the sine of 1? So if t is 1, obviously we didn't construct it per se on our unit circle guide, but I think we'd be able to ballpark it. Which quadrant would we be in if we went 1 unit around the unit circle? Well, again, that comes back to our little demarcations right up here. The 1.57, this, and then this, and then this. Well, if I've gotten 1 unit around, I haven't even hit here. I've got about right there, give or take. And would sine be positive or negative if I'm up here? And I think everyone would be in agreement if we're in the first quadrant, sine is positive. How about this one? What about cosine of 2.43? Again, just making stuff up here because t can be any number. Well, if you've gotten 2.43 units around the coordinate plane, which quadrant would you be in? Well, 2.43 would probably be somewhere in here, give or take, in that second quadrant, because it's in between this number and this number. And so if I'm in the second quadrant, everybody, what do we know about cosine? Well, when I hear cosine, I think x, and x is negative in the second quadrant. Okay, good. How about this one here? How about sine of 6.14? Okay, so if you've gotten 6.14 units around the unit circle, looks like I would end up really, really close to my once around, probably right in there, give or take. And what do you think? Is sine going to be positive or negative as a result? And down in the fourth quadrant, of course, it looks like I'd have to go with a negative on sine. So if you know where you are, again, it comes up time and time again, then you should have a good sense of what we're looking for here. Now the last thing is this. How about approximating? So here's what I'll start you out with. Something like this. What if I asked you for the cosine of 1.5? Would you tell me that that number is closer to 0, closer to 1, or closer to negative 1? That's, I guess, what I'm thinking here. So if I asked you for 1.5 and its cosine value, what do you think? Well, let's take a look. If you've gotten 1.5 units around the unit circle, I'm hoping everyone would be in agreement. We're probably right about there, give or take, just before the pi over 2. And in this case, if I'm looking for cosine, do you think that the cosine value, the x value, if I'm right here, is closer to 0 or closer to 1 or closer to negative 1? Well, in this case, it looks like it's the x value. It looks like it's very close. I'm not moving horizontally off that origin very much at all to get there. So it looks like it has to be closer to 0. So close to 0. And that's exactly how we'll do it. Now, if you look, as a matter of fact, let's pull it up on the calculator to see if that works. So I have cosine. Let's take a look. Cosine of 1.5. And you can see it's a number pretty close to 0. It's positive because we're in the first quadrant. And it's close to 0. What if I went just beyond the pi over 2? What if I said like cosine of 1.6? Same thing. Very, very close to that pi over 2. So very close to 0, but as you can see, everyone, negative. So it's beautiful how it really works out according to the way we've developed this. Let's try this, something along these lines. What if I asked you for about the cosine of 3.2? Do you think that would be closer to 0, closer to 1, closer to negative 1? Well, let's see. 3.2 would probably be about right here, give or take, just beyond pi. Cosine, think x. So horizontally, am I going pretty far or pretty close to that negative 1 there? Yeah, absolutely. So I'm hoping everybody would be in agreement that probably close to -1, because cosine of pi is -1, and 3.2 is really close to that. Let's pick it up. So cosine 3.2, and as you can see, really close to -1. Try one more here. How about this? How about sine of, oh, I don't know. How about sine of 4.68? Okay, so let's see. 4.68 is probably super close to that 3 pi over 2 right in there. And vertically, do you think it's going to be closer to 0, closer to 1, closer to -1? Well, obviously, I'm not going up, so it's not closer to 1. And look how far down I'm going, really close to the -1. So sine of 4.68, close to -1. Let's check it out. And here we go, sine. What did I say there? 4.68. And look how close. So really should match exactly what we're doing. How about just one more good approximation? We'll check it on the calculator and wrap this on up. What if I asked you for like the sine of, I don't know, let's see. How about the sine of 1? We said it's going to be positive. What do you think? So, it's tough to tell here. But I would say if you went 1 unit around the unit circle, you're probably somewhere in here, give or take. I'm just a ballpark at best. And this might be helpful with your study guide, this last one of the day. But basically, I would argue that if you're 1 unit around, you're probably somewhere right in here. And if I think sine, then I'm thinking about what is the y coordinate. And I don't know what this is. If I had to take an educated guess here, I would say, knowing that it's right in there, it's probably around 0.8, 0.9, somewhere in there, give or take. Maybe a little below, maybe a little above, but it should match. So I would think of what is the y coordinate right here on the unit circle. And again, you could probably see it on your study guide better than here, but I would say it's somewhere in the 0.8, 0.9 range. Well, let's just see it about 4 decimal places what that is. Sine of 1, not bad. Again, I was at least within the vicinity. So we would typically go out to about 4 decimal places, 0.8415. So what you should do is take a look at some of these, kind of challenge yourself a little bit. Just give yourself any random t-value and, approximate. What would you say is the cosine value or the sine value based on where you are? Okay, this was a long one, a long study session with this, but at this stage should be able to work through a good portion of these without your study guide. You're going to try to keep weaning yourself off over the course of this unit. And, obviously anything I can do to further explain, help on any of these types, you let me know. Thanks for listening. I definitely appreciate it, and I hope the practice portion here was helpful for you.